Okay, so the first of our key features that we're going to be talking about, we're really going to do two together, are the extrema, which are your minima and maxima, and then also the increasing and decreasing intervals. So on your worksheet, you have 5 steps to find the mins and maxes. This you're going to be doing in the calculator. The only way that you are going to algebraically be finding the mins and maxes is if you have a parabola, right? Because the mins and maxes, those are the vertex. So you're going to be putting it into vertex form. So these are your steps. First, you are going to type the equation into y equals. Type the equation into y equals. Then you're going to press second, trace, and you see two options that say minima and maxima. So number 3 is if you're looking for a min, or number 4 is if you're looking for a max. Then it's going to say left bound. So you need to move the cursor to the left side, somewhere on the left side of the min or max. So for example, I have this little graph on the side on the right of your worksheet. So if this is the maximum, you're going to be somewhere over here to be on the left side. Then you're going to press enter. And then it's going to say right bound. So then you're going to move your cursor somewhere on the right side. And then it's going to say guess. And you are not going to move your cursor over at all. You're just going to press enter. And that way it's going to approximate what point is either the maximum or the minimum that's in between those two values that you just gave. So if you're looking for a min, you have to make sure that you're choosing min. If you're looking for a max, you have to make sure you're choosing max. Otherwise, you're going to get the question wrong. So the other thing that's important to note is that you can have up to one less extrema than the degree of the polynomial. So for example, if you have x to the third, you can only have up to 2 mins and maxes in total. If you have x to the fifth, you can only have up to 4 mins and maxes total. So let's look at these two examples down here. And I'll show you how to find the mins and maxes. We are rounding to the nearest thousandth. So I go into my calculator, and I'm going to type in x to the third. X to the third and then plus 2x squared minus 3x minus 4. And I press graph. So this is what this function looks like. So I am just going to, on my paper, I am going to just draw a little sketch of it. So this looks something like this. So on this, we have one max, right? That's a max, and one min. Doesn't matter which one you find first. So I'm going to go back into my calculator because I'm going to do all this in the calculator. To find the first max, I am going to press second, trace, and then maximum is number 4. So this is the point that I'm looking for up here. So I'm going to go a little bit to the left side of it because that's what's asking me for, left bound. I'm not going to go crazy far away, but I'm not going to be right on top of it either. I want to make sure that I definitely see that it's somewhere to the left. Press enter. Then you're going to do the same thing but go to the right side. Press enter. Guess, enter. Do not move it. And then this is your answer. We're rounding to the nearest thousandth. So it's going to be negative 1.869, comma 2.065. Again, that point was negative 1.869 and 2.065. Now I'm going to do the same thing, but now I'm going to find the min. So I'm going to go back into my calculator, and I start over. So I'm going to press second, trace. Now I'm going to choose option 3 because I'm looking for a minimum. I move my cursor. You can go right on top of the point if you want to. That way you see where you are, and then you back up. That way you're a little bit to the left. Press enter. Then you move to the right side of the point. Press enter, guess, enter. And we get 0.535, comma negative 4.879. Again, we're rounding to the nearest thousandth, which is 3 decimal places. And that's it. That's all you have to do for these two examples to find the relative extrema. So now we're going to do the same thing. We're going to do it for number 2. So I go to y equals. I'm going to clear out my old function. I'm not going to add another one in because then it's going to graph too much. I have negative x to the 4th plus 8x squared plus 5. Oop, that should be an 8. Plus 8x squared plus 5, press graph. So now when I see this graph, we have a little bit of an issue, and that's that you have these two maximums that you cannot actually see. So I want my graph to go up more, okay? Up and down deals with the y value. So I want to increase, if I go to my window, I want to increase my y max. That way I go up more. So I'm going to make it 20, and let's see what happens. So when I make it 20, it's almost there, but it's not exactly there. So I'm going to go back to my window, and I'm going to make it 30. You can still do this with it being 20, but I just want you guys to actually see the maximum. There we go. That means that y value is going to be somewhere in between 20 and 30. So I come back. I'm going to draw a little sketch on my paper. Now this one's different. This one, I have an extra extrema, right? I have a max right here. I have a max right here. And I have a min down here. And the reason why this one, number 2, has one more extrema than the other one is because this one is an x to the 4th. This is a 4th degree polynomial. So when you find the maxes, you're just going to list 2 of them. And then when you find the min, you're just going to list the 1. So I go back to my calculator. I'm going to go into second, trace, number 4 for max. I'm going to find the max first. Left bound, enter. Right bound, enter. Guess, enter. Negative 2, comma 21. So this one's nice, so you don't even have to round. Negative 2, comma 21, which makes sense because we didn't see it at 20, but it was really close, right? Now I'm going to do the same thing, but I'm going to find the minimum. You can do them in whatever order that you want. Just make sure that you're careful and you're choosing minimum for minimum, maximum for maximum. Right bound, enter, guess, enter. So this minimum, I don't know if you guys can see this that well or not. It's a little bit better. So this minimum, you see that this point is on the y-axis, which means your x value should be 0. You have this number here, 1.7259e, and then negative 6. E is scientific notation. So this is like times 10 to the negative 6. So it's actually 0.000017259. Okay, I don't know if I got the right number of zeros, but that's what it would be. So I'm going to explain that more in class. But whenever you see an E, whenever you're doing this stuff, just know that that means that that point is 0, comma, and then the y value was a 5. And then for the other max, second trace, I'm looking for a max, so I choose 4. I need to be on the left side, and then it needs to be on the right side, and then I press enter. And I get 2.000011, comma 21. That's really just going to be 2, comma 21. So positive 2, 21 is the other max. So that's how you find the max and the min. Now the other thing we're going to practice with is the intervals for increasing and decreasing. And the reason why we do this together is because you need the mins and maxes in order to do this. They kind of go hand in hand. Okay, so to find the intervals of increasing and decreasing, these are going to be your steps. First, you are going to draw a sketch. Just a quick sketch, nothing crazy. Then you're going to find all extrema, so all the mins and maxes. Then your third step, you're going to draw a number line. This is going to organize it for you. Draw a number line and plot the x values of the extrema. Just the x values. You're not going to plot the whole point. Extrema. Then, on your number line, you're going to plot a plus sign where the function increases. So where your function's going up. And you're going to also plot a minus sign where your function decreases. And then step 5, last thing, using that, you then are going to just rewrite in interval notation. Again, you really don't need the number line. It's just there to kind of organize your thoughts. It's a lot that's going to be going on. All right, so let's try these 2 examples. So we're going to stick to the same functions that we just used. That way we don't have to find the mins and maxes again, but now we're going to find the intervals of increasing and decreasing. So I'm just going to quickly resketch my graph. So this one looked like this. And this one looked like this. Okay. So this maximum right here, this point is negative 1.869, comma 2.065. Already found that. So your first 2 steps are kind of done. And then the min is 0.535, negative 4.879. Okay. So this is what you're going to do for your number line. On your number line, you are going to draw negative infinity to positive infinity, because that's going to be your domain for all polynomial functions. You're always going to go from negative infinity to positive infinity. Then you are going to draw little slashes, and you're going to put the x values of the mins and maxes. Remember, it's a number line, so it has to be in order. So this first one's going to be negative 1.869, and then the other one is going to be 0.535. Okay, so we read graphs just like how we read novels, right? We read from left to right. So you're going to start at your leftmost arrow, which is right here. And as you start, we are going up. So we are increasing until we hit the max. Your max and your min, those are your turning points. So that's where you change back and forth between increasing and decreasing. So once I hit that max, I then start to come down until I hit the min. So I'm decreasing. Then I turn around again at the minimum, and then I start to increase again. These are going to go back and forth on your number line. So my interval is going to literally just come right off of the number line, essentially. So for increasing, this is still for number 1. For increasing, we start off at negative infinity. And we are increasing until negative 1.869. Then, at negative 1.869, we start to decrease until 0.535. Then at 0.535, we pick back up and we start to increase again. So then we have 0.535, and we keep increasing until infinity. Now, whenever you have more than one interval, you're going to put a U in the middle of them. That means or, so you have 2 intervals for increasing. All right, and that's it. So once you have your number line, the increasing and decreasing interval is a little bit easier. All right, so let's try this for number 2. I'm going to erase this, that way we have some room. So if you need to pause it to copy, then do so now. Okay. For number 2, we had our mins and maxes were a little bit nicer of numbers. So this max was negative 2, 21. This min was at 0, 5. And then this max was at 2, 21. So my number line, it's going to have one more little notch on it because I have one more extrema than I did before. So the first one is negative 2, then the middle one is 0, and then 2. Remember, it's a number line, so it should be in order. So from my leftmost arrow, I start off right away. I am going up, so I am increasing to start. Then I hit this max, and then I start to come down, and I am decreasing. Then I change direction again at the minimum, and I go up to reach the maximum, so I am increasing. And then from 2 until infinity, my function is going down, so I am decreasing. I understand that 2 to infinity, those numbers are increasing, but those are the x values. I don't care about the x values, I care about the y, so it's where your function is headed. So then for my intervals, I have increasing and decreasing. So I start off by increasing. So I increase from negative infinity until negative 2. Then I'm decreasing from negative 2 until 0. Then I'm increasing again, so I put a U, from 0 until 2. And then I'm decreasing again, so another U, from 2 until infinity. Okay, so again, your mins and maxes are your turning point. So that's why you're changing directions there, which is why your intervals have your x values for the mins and maxes. Okay, again, we're going to practice this in class if you have any questions. So we'll make sure that we are good to go with the calculator stuff before we move on. All right, that's it. Have a great day.